Hello, everyone, and thank you all for joining us today. I'm Bob Crossan, Senior Managing Editor of Water and Waste Digest. On behalf of Water and Waste Digest and our sponsor, Veolia Water Technologies, I'd like to welcome you to today's presentation titled Hollister Urban Areas Alternative Approach to Meeting Growing Drinking Water Demand. Facing an increasing demand on drinking water versus groundwater, the San Diego County Water District, in a joint effort with the Sunny Slope County Water District, turned to local reservoirs as alternative sources to reduce the impact on the local groundwater basins, as well as the hardness and scaling challenges with groundwater. The culmination of efforts led to the construction of the 4.5 million gallon per day West Hills Water Treatment Plant to include Actiflo Carb. This presentation will focus on the project history, its drivers, and the operational aspects of how this alternative approach has helped to succeed the district's goals. During the course of this webinar, viewers will learn how to reduce the impact on groundwater, how to treat very raw water sources and blends, how to reduce TOC without GAC filters, and how to meet DBPs with ballasted and PAC. Veolia Water Group is a global leader in optimized resource management with more than 169,000 employees worldwide. The group designs and provides water, waste, and energy management solutions that contribute to the sustainable development of communities and industries. Through its three complementary business activities, Veolia helps to develop access to resources, preserve available resources, and replenish them. We're going to get started in just a couple of minutes, but first a little housekeeping. You will notice on your viewer that you have the ability to ask questions, and we encourage you to ask questions, and we will try to get to as many as we can by the end of the presentation based on time availability. Any questions we don't get to, we will answer offline. So today, our presenters are Billy Boltz, Richard Stratton, and Reed Stanton. Billy Boltz is the plant operator for the West Hills Water Treatment Plant, which is part of the Sunny Slope County Water District in Hollister, California. He has been in the water industry since 1993 and began his career with the Cuesta La Honda Public Works, where he was awarded an Above and Beyond the Call of Duty Award for his role in spearheading the upgrade of a new water treatment plant. This resulted in cost savings for the city. In 2006, he took a job working for the San Jose Water Company. There, he worked in operations and water treatment until 2017 before moving on to Sunny Slope County Water District in Hollister, California. There, he was part of putting the new constructed West Hills Water Treatment Plant online, featuring the Actiflo Carb system. He is still operating the West Hills WTP today, and he currently holds his T3 treatment license with the state of California and is the president of the local 820 Utility Workers Union of America. We also have Richard Stratton. He is a PE and senior project manager for HDR. He has been with HDR for 20 years and has experience working in conventional water treatment plants and advanced water purification treatment plants for indirect potable reuse. He also worked in the fields of membrane treatment, reverse osmosis, and desalination, as well as groundwater biological treatment. Richard designed and worked with regulators to permit the first drinking water Actiflo and Actiflo Carb systems in California. He received a Bachelor of Science in Civil Engineering and a Master of Science in Environmental Engineering from the University of Illinois, Urbana, and has professional memberships with American Water Works Association and the American Membrane Technology Association. Lastly, we have Reed Stanton. He is the U.S. Product Manager for Veolia's Actiflo Ballasted Clarification System. Located in Raleigh, North Carolina, he has a degree in mechanical engineering from North Carolina State University and has been with Veolia for more than 19 years. His prior positions with Veolia include mechanical and process engineer and process manager. He has extensive experience with engineering and operation of physical and chemical separation and filtration processes for water and wastewater treatment. Now with that, I'd like to turn it over to our speakers. So Reed, the floor is yours.
Thank you, Bob. And thanks to Water and Waste Digest for hosting us today, and thanks to all of you who have joined us as well. Alongside Rich Stratton, and Billy Boltz. I'm Reed Stanton, and today we are excited to talk about a collaborative effort between a couple of districts in California and their successful implementation of an alternative solution to handling a variety of challenges with their new drinking water facility. I just want to quickly highlight the contents that we'll talk about today, background and drivers of the project as a whole. We'll talk about one of the selected processes associated with the treatment train, the Actiflo Carb process. Then we'll jump specifically into the West Hills Water Treatment Facility, provide an overview talk about some operation and performance of that plant, and then wrap up with with a summary and any questions you may have. So with that, I will transition over to Rich Stratton with HDR to talk about the project background.
Thanks, Reed. So the Hollister urban area is located south of San Jose in San Benito County, and they have a current average demand of about 6.5 MGD, max day demand around 13 MGD. The demand is projected to go as high as 18 to 20 MGD in about 20, 30 years. There's two main surface water supplies that serve the system. Other than groundwater, there's the San Luis Reservoir and the San Justo Reservoir. There's an existing plant called the Les Salt plant that uses membranes that uses these sources right now, but primarily they're on the rest of the system is on groundwater. So the two sources, surface water sources, are San Luis Reservoir, as I mentioned. That's part of the State Water Project, California State Water Project. It has moderate TOC, although it can get high at times. It's low NTU. It's a good quality as far as that's concerned. Seasonal manganese issues, and there can be high DBP formation, primarily due to bromide, because the water comes out of the Sacramento-San Joaquin River Delta, and seawater intrusion happens and bromides get into the water source. The San Justo Reservoir is a balancing reservoir that takes water from San Luis Reservoir and stores it for irrigation needs and balancing purposes. That reservoir causes the TOC to go even higher because of the stratification that occurs every year. So there'll be low DO and higher iron and manganese levels potentially. The effluent goal for the project was based on jar testing and other testing. We found that we had to get the TOC below 1.2 milligram per liter, and more ideally even down less than 1 milligram per liter, in order to meet the goals of total trihalomethane and HAA5 of 80% of their MCL. So this is a look at the San Luis Reservoir water quality. It's a little bit dated, but it hasn't changed too much, I think, over many years. The turbidity average is 3, max 95 percentile of, say, around 6. And then the bromide can get high as 0.4 milligram per liter, which is problematic, as many of you may know, for DBP formation. You can see that there is iron and manganese present at times. Normally it's low, but it can come up. And then the TOC average and DOC are pretty much the same at about a max of about 3.8, although historically it's been as high as 5 milligram per liter. So the San Justo Reservoir, because of the stratification, and I should mention that the outlet of the reservoir is at the bottom. And so all the water that comes to the water plant has to come out of the bottom of the lower part of the stratified reservoir. So that's the poorer quality water oftentimes, and it will have a very high chlorine demand, high DOC. The same bromide that's in the San Luis Reservoir water is there. And some may ask, well, why don't you just, mix the reservoir and break the stratification? Well, the reason for that is there's also zebra mussels in the reservoir, unfortunately. And in order to control those, they found that leaving the reservoir stratified with low DO in the lower level helps control the zebra mussel. So until there's a solution to the zebra mussel, they have to keep operating in this stratified mode. So we did an evaluation of different alternatives. The challenge was to meet the disinfection byproduct goal, 64 parts per billion on TTHM and 48 for HAA5, from water from the Sacramento-San Joaquin River Delta, which most plants and many large systems in the state of California chloraminate their water. but the district and the cities did not want chlorinated water, which is, there's issues with chloramines. And so they wanted free chlorine in their, as a residual in their system. So that required a very aggressive amount of TOC removal. And so we found that just enhanced coagulation was not going to be sufficient. And so we looked at options such as nanofiltration membranes, resin adsorption, GAC, and we did an analysis and we found that the Actiflo Carb was the preferred alternative because of you could dial in the amount of PAC that you needed depending on water quality, and that ended up being less cost than replacing GAC. And I believe that the less salt plant uses GAC, and that is a high cost for them, replacement of GAC. And a pilot test was run, and the results showed that the Actiflo Carb could meet the TOC removal and the disinfection byproduct goals. And so the project proceeded with the Actiflo Carb. And I'll just turn it over now back to Reed.
Perfect. Thanks, Rich. So real quick, I wanted to just jump in and talk about, before we transition to the West Hills water treatment facility, I wanted to talk about the Actiflo Carb process. And for those of you not familiar with Actiflo Carb, it's the combination of high rate ballast declarification, which I'll dig into a little bit further on the next slide, along with the adsorptive properties of activated carbon. So it combines the benefits of coagulant addition along with those adsorption properties and the ability for carbon to go after the more refractory compounds in water that are more challenging to remove through coagulation alone. When we talk about drinking water, this obviously includes organics that are typically of the lower molecular weight aspects that are difficult to remove through coagulation. Obviously, in drinking water, taste and odor, potentially pesticides is also a compound that carbon has a very high affinity to remove, but also the toxins associated with algae. That's another compound that carbon is effective. And then when we expand the net, so to speak, hydrocarbons, but also emerging micropollutants. We talk about personal care products, pharmaceuticals, EDCs, PFOS, PFAS. Carbon has affinity and is well known for removing all those various compounds. Real quick, I want to highlight high rate ballast declarification. In this case, when we talk about that, we're referring to Actiflo. Actiflo, again, combines your typical coagulation, flocculation aspect of basic water chemistry and enhances it with ballast addition. So it adds that weight to the colloidal material to afford rapid and efficient settling in a very compact footprint. Actiflo is well known in a variety of applications, including drinking water, which is the focus here, but also industrial in a wide range of industrial applications, but also municipal wastewater as well. When we talk about the various applications, primary clarification, tertiary clarification for enhanced phosphorus, but also in peak excess flows during wet weather as well. So how does Actiflo work? A little bit of coagulant upstream, really to begin the destabilization and agglomeration of colloidal and dissolved matter. That pin flock, as it starts to develop in the coagulation zone, is then matured and bound to the ballast in the maturation zone. And we enhance that maturation zone with Turbomix draft tube, which provides a number of benefits, provides very efficient mixing in terms of power input, provides and minimizes any short circuiting within that maturation zone, which is critical to make sure you have the right residence time. And it really promotes and aids in developing of that very dense, heavy ballasted flock that then, as it enters in the settling tank, settles out quickly and efficiently. Effluent will then carry through lamella tubes before exiting the system, and these ballasts, as they drop to the bottom of the settling tank, are collected and pumped to a separation device, in this case a hydrocyclone, that separates and recycles the microsand back into the maturation tank, and then of course the lighter solids that are captured or discharged from the process. Switching gears back to Actiflo Carb, again, taking advantage of the benefits of high rate clarification and ballast deflocculation with respect to short residence time and rapid response and the ability to push a given amount of flow in a smaller footprint in terms of gallons per minute per square foot. And then combining that with the benefits of PAC. And we do this through an upstream absorption tank, as well as a recycle of the powder activated carbon through the process. And overall, Actiflo Carb has shown the efficiency of taking and maximizing all the absorption sites available for a given granule PAC, and therefore providing a more overall effective dose of carbon compared to once passed through systems. How does it work? So we add a little bit of fresh carbon upstream, and then flow enters into the absorption or PAC contact tank, really given an amount of time to really interact with the raw water, focused on the absorption of those compounds that are difficult to remove through coagulation alone. And then these PAC particles then enter into the active flow portion, the coagulation, the flocculation, and of course then bound to the ballast, creating that ballasted floc with these PAC particles that settle out quickly and efficiently. Just like Actiflo, these solids settle out. We pull pump-wise to a hydrocyclone to separate the sand from the PAC and sludge that's generated, recycling that microsand back to the maturation tank. And then the majority of the solids, that exit the top of the hydrocyclone, this again, majority of PAC and any solids that we've generated through a little bit of coagulant addition, the majority of that flow is recycled back to the absorption tank. Again, keeping the PAC within the system for an extended period of time. And as we fully utilize those absorption sites and essentially spent the PAC, that wasted PAC has been discharged. A very small side stream is discharged as waste. Quickly highlight, how else Actiflo Carb really benefits in these situations, i.e. specifically to West Hills. We inventory a large amount of PAC within the process. Typically, depending on the application, anywhere from 1,000 to 2,000 milligram per liter. And it results in a very long pack age within the process. As I mentioned, we're dosing a small amount of carbon up front, and then we recycle the majority of that carbon through the process. And it results in pack ages of 18, 24, 28 hours, really taking advantage of all those absorption sites before we waste the used pack. Again, that recycled pack and the fresh pack, take advantage of the contact time in the absorption tank, typically 5 to 15 minutes, but obviously dependent on the compounds that we're targeting with Actiflo Carb. And both of those result in a very effective low fresh pack dose, again, adjustable based on what you're trying to achieve. And again, Actiflo Carb combines the benefits of ballasted clarification. So it does all of this in a very small, compact footprint with short residence time. We talk PAC. I think most of us are familiar with the efficiency of carbon with respect to organic removal, and just kind of really want to highlight that. The U.S. EPA has obviously established through stage 1 and stage 2 guidelines for disinfection byproduct removal. I think most of us are familiar with this table when we talk about enhanced coagulation and what coagulation is capable of in terms of organic removal. This chart here, plots the removal of organics as a function of influent TOC and influent alkalinity. Depending on, the constituents that any given utility or plant has to deal with, obviously will drive the ability to meet the disinfection byproducts. And in the case of West Hills, as Rich pointed out, what happens when coagulation alone isn't sufficient enough. West Hills falls in line with about 35% removal needed. And as Rich mentioned, due to various other compounds and the formation potential associated with those, coagulation alone was found not to be sufficient. So as West Hills went through, as Rich alluded to, and in the other facilities, looking at how low do we need to go from an effluent TOC or DOC perspective, oftentimes that results in some type of simulated distribution test, really analyzing for a given TOC, what is the resultant disinfection byproduct in terms of TT, HM, and HA5s in order to meet those guidelines for 80 and 60 microgram per liter, respectively. And this is just one example, plotting that curve, comparing those disinfection byproducts to effluent TOC. And in this one example, you can see the threshold is around 2 milligram per liter to ensure that you meet those disinfection byproduct guidelines for 80 and 60 microgram per liter. So, as mentioned, carbon is very effective at dealing with a number of compounds. Organic removal is very efficient, but it's also not selective. It'll absorb essentially whatever it sees with your incoming source. Here's some data from a couple of different sites. The left side of the slide here representing Actiflo Carb facility in Indianapolis, which is seasonally based. They operate it seasonally as needed for taste and odor issues, geosmin and MIB. In the upper left-hand corner here, this is actually pilot data collected from that study or that facility, looking at various incremental increases in the influent side with respect to geosmin and MIB, and the ability of Actiflo Carb and that carbon to effectively provide consistent effluent quality, and then also pesticides for this facility. Many source waters are impacted by runoff, especially if there's agricultural influences in the surrounding area, and so pesticides can be problematic. Again, Actiflo Carb and carbon have shown an affinity in this case to remove those as well. Shifting gears to the wastewater side, looking at pharmaceuticals, the study on the right is a pilot that was conducted on a tertiary wastewater application, looking at the removal efficiency of carbon as it compares to pharmaceutical removal here. And what we're looking at is varying dosages, 10 and 20 milligram per liter in various pharmaceutical compounds. And as you can see, for the majority of these compounds, Actiflo Carb and associated carbon dose was able to effectively remove these compounds very efficiently. So when evaluating any technology, obviously there are a number of technical considerations. Rich kind of talked about that in the upfront evaluation, but these are just highlighting a few of those, and a lot of these were important to the West Hills facility, and we'll talk about these a little bit further. But just wanted to highlight flexibility. It's an important component when dealing with various challenges with your influent source. Actiflo Carb provide a very short hydraulic residence time, not only the ability to quickly start up, but also the ability to quickly adapt to those changes on your influent side. And there's a graph in the lower right-hand corner here that represents, the ability of Actiflo to reach steady state. We typically say 1 to 2 HRTs. With Actiflo, the hydraulic residence time through the basin is 8 to 10 minutes. And so you can see with respect to this graph with, 100 to 160 NTU, within 15 to 20 minutes, Actiflo is providing a very stable, high removal percentage of the turbidity coming in. Robustness as well, with the amount of microsand that's inventoried within both Actiflo and Actiflo Carb, it's significantly greater than anything that we'll see on the influent concentration side, whether it's TSS or algae or what have you. The ballast and the amount of ballast that we maintain is significantly greater. So any variation with respect to influent load really has no impact on the performance of the Actiflo or Actiflo Carb. Same as flow as well, that any variations in flow is really dampened by that inventory of sand or of microsand. So it provides a very stable effluent quality and allows for the process to really handle sudden changes in flow rate and concentration. And again, when you consider the ballast and the weight that microsand provides with a specific gravity of 2.65, it affords these coagulated material to set out very efficiently and very rapidly, allowing for high throughputs in terms of gallons per minute per square foot. So the ability to treat a high volume in a small footprint, which is great for facilities that have very limited space, but also opens up opportunities for rehabilitation or retrofit of existing basins to help overall minimize construction costs. Real quick, I wanted to highlight, as Rich mentioned, there was an exhaustive exercise up front looking at the two source waters and really what they needed to do from a treatment perspective to meet the ultimate water quality goals. And this is highlighting just some of the data associated with the Actiflo Carb pilot. It was a 6-week study in early 2011, highlighting the 3 different phases. And we talked about 3 different phases. The first 2 phases were dedicated to those individual water sources, San Luis and San Justo, and that third phase was a blend of the two. And Billy will talk about the challenges associated with those 2 sources and how it impacts operation, but just wanted to highlight the efficiency of the Actiflo Carb pilot with respect to effluent turbidity removal, TOC removal, and then ultimately meeting the THM and HA5 goals. So, shifting gears to West Hills and talking specifically about that water treatment facility. As I mentioned, the pilot was concluded in 2011. It was an extensive effort in terms of detailed engineering, ultimately resulting in a project award in 2015 for the $23 million project. Construction phase was approximately 2 years, and then finished with commissioning of the facility in 2017 and then acceptance testing later that year in December. So now I will hand it off to Billy Boltz and have him talk more in depth about the facility as a whole.
Yeah, hello everybody. This is Billy Boltz with West Hills Water Treatment Plant, and I'm going to give you guys kind of a oversight of what it is to actually run the plant, seeming I'm the operator here that was the one that put it online with some other guys. So the current slide that we have up right now is kind of a footprint of the plant. You can see to the left is our sources. We have San Luis and San Justo. If you can kind of follow along, we have a raw water pump station, which pumps the water up to the plant. At that point, the raw water station, we add sodium permanganate to help with the iron and manganese removal. We also found out later that's a very effective way to kill zebra mussels in case any of them get by through the San Justo Reservoir. We have a second line of defense, so that doesn't get into all of our equipment. As you go up the line, we start adding sulfuric acid to help optimize the coagulation. We drive that pH down, and right before the Actiflo train there is where we add the PAC, the powder activated carbon. So once that kind of goes through the train, when it comes out the other side, now we have a very low pH. We have to use sodium hydroxide to raise that pH, which helps precipitate out the iron and manganese, goes through the filters, goes to the clear well, where we chlorinate it, meet our CT times, and that goes to onto the town. This next slide is kind of a footprint of the plant. If you can see the middle one up towards the top where you see the drying beds, that's where the PAC waste pumps, when Reed was talking about how we recirculate some of the PAC and then some of it's wasted. That's where the PAC ends up going. Then we dry that out and we haul that off to the landfill. You can kind of see we have our chemical storages. You can see the train from a top view there. The next slide is one that hold on. We're going to talk about the operational challenges that this particular plant, that is what we have to deal with for what our situation is. Every plant will probably be a little bit different, but this is what we deal with. So having the two raw water reservoirs is not as much of a challenge as you would think, except for at times we get a source change without any notification. So we have to look for things like the DO change and different stuff as that comes down the pike on things that we're going to change in the filter plant. Another one of the challenges that we have is at times they use the San Justo Reservoir as like a pop-off where they have a valve crack to that and the water's coming from San Luis Reservoir feeding the plant and then slowly filling San Justo. But as the downstream pumping for the irrigation starts, then the water will reverse and start coming out of San Justo, and then that will influence the filter plant. And then now we have a different source change without, knowing that. So those are some of the challenges that we have at this particular plant. At a time, it can be a blend. You don't know which way it's going to go, but you learn your plant and you'll figure it out. Going to the next slide is our daily operations. So I wanted to kind of give you an overview of how we handle these source changes and how we adapt to it. Our daily routine is our daily routine. We normally just, do your daily log sheets, keep good records of everything that's happening. On a daily routine, after we take our sand grabs and different stuff, we like to keep the hydrocyclones, washed down because you get, a lot of packs splashing up. Keep that. We clean our TSS probe daily. We've had problems with that drifting off. We've found that our TSS probes, if we clean the lens daily, then we don't have that drifting. So if your TSS probe starts drifting, then you won't get your pack wasting that you need to get. And every single day, we also clean our pack wetting bowl and the pack tank and the pack silo because we've had problems with the pack building up and then you get an overflow. So those are just challenges that we deal with day to day on like a boots on the ground type of deal. So for indicators of the source change, we're always looking for the DO changing. That's like our first indicator. We look for the raw water pH changing. This particular plant likes a DO about 3.0 or higher. So once we find that the DO is dropping, this plant needs a lot more sulfuric to get the coagulation process to work. So as the DO drops, we have to increase the sulfuric. And as it raises, then we can back off. And then the other challenge is at the other end of the Actiflo train, we've driven the pH down, so now we need to get that back up. So we'll add sodium hydroxide to bring that pH back up. Some of the things that we keep an eye on that is very important for these type of plants is to keep an eye on your waste times. Typically at our filter plant, we look at the waste times on our pack waste pumps in the morning. We should have about 3 to 4 hours. If it's more than that, then you're wasting too much. If it's less than that, then your pack is building up. And what you don't want to happen is the pack to get too much and then it has nowhere to go and you haven't wasted enough and then it'll burp out the other way into your filters and cause problems. We've had those problems, but we've learned from all those problems, and that's why we learned to watch the pack waste pump times. We keep a daily log to track the changes that we've made, like most plants should do. We stay in touch with the manufacturer for updates, advice, improvements, and lessons learned. Veolia has been great. As we went online with this plant, we had a lot of challenges, a lot of learning curves. They've always been available for us to call and help coach us through things. All the vendors involved on this project, from the people who put the pack silos in to the chemical feed pumps, everybody's been really good on this project for us to reach out to and get help and understand things as we went along. Some of the benefits of Actiflo Carb, I would say, is the quick settling times. How I prove that to people is I take an MHOF cone read, and in front of their eyes, you can see how fast the settling times is on a plant like this. I'm pretty impressed. Process stability, this particular plant, we can pretty much set our chemical dosages and go with it. We don't have to change them daily. We maybe make chemical dose changes maybe 4 times a year on this plant. Our ability to run remotely, so we don't have to staff this plant 24 hours a day. Our SCADA will call us on a smartphone and let us know if there's a problem. We're able to log in, make changes remotely, acknowledge alarms, and also check on the process. Robust. The handling of turbidity spikes without major chemical changes has been one big key factor in this plant to us. We've had going at like 3 NTU and a spike come through at like 100 NTU, and this plant handled it no problem without any chemical adjustments. On this next slide, on the performance, I just wanted to point a couple things out on the bottom row. Is our average acid dose is about 5.9. That's meaning that's what we drive the pH down to. But one thing I wanted to point out is that on the settled effluent NTU, we have an average of about 0.58. Those are highs of our day that was taken, so we're actually more averaging like a 0.12 to a 0.14. And if you can see what the raw water NTU is, that's quite a reduction in the NTUs. So we're pretty happy with that. And you can see also on the TOCs, going from a 3.17 to a 0.74. Our lows can be down to a 0.600 or a 0.500, which again is a pretty good reduction. So overall, we've been very happy with the performance of this plant. We've been very happy with the tech support and all the support we've gotten from Veolia. And I'll kind of leave it at that. Sorry if I stumbled a lot. I'm kind of new to this, but I'll answer any questions later on if anybody has. And I'm going to give it back to Reed right now.
Perfect. Thanks, Billy. I do actually, I want to back up on you. I think this is great data, and just kind of want to reiterate a few things that we talked about that you highlighted. We talked about the Actiflo Carb process really being the combination of coagulation plus the absorptive properties of carbon, and how it harnesses those abilities of the ballast declarification. And that I think what strikes me is the efficiency of the removal of the turbidity. As you mentioned, 100 NTU at times, even though it's a clean source on average. The ballast declarification and the efficiency of that. Really, as you mentioned, it just hummed along with that turbidity spike, which is, most surface water plants are prone to. So Actiflo Carb can operate as a primary clarifier as well. And then we talk about sand usage. With any ballast declarification system, there is some level of sand usage. From an Actiflo and Actiflo Carb perspective, when we look at the overall OPEX associated with sand, it's typically less than 1% of the overall OPEX. So it's a very minor amount of cost. But when we look at the usage rates here that you guys have seen at West Hills, at most it's 9.2 pounds per million gallons of water treated, and then over the last 3 months or so, there's been little to no sand addition. So it's important to note that on average, at least over these 5 months, that you're seeing 3 pounds per million gallons, and ultimately reducing your overall OPEX. So with that, real quick, just want to highlight a quick overview. As we all talked about, with Rich and Billy, the main drivers for Hollister, was to improve their water supply reliability. They were pretty much predominantly dedicated to groundwater, and they were looking to shift away from that a little bit to reduce their dependence on it, but also reduce their impact on their groundwater. Shifting the surface water obviously results in some additional challenges, as pointed out, with respect to the DO issues and the muscle issues and the precursors there that create challenges with meeting DBPs. So very important drivers for the district. But also, given the two sources and the unknowns associated with when they get these variations in sources, it was important to find a treatment train that provides that flexibility, not only proven and robust, but flexible enough to adapt and flexible enough to successfully handle these variations and meet Hollister's water quality goals. And I think Actiflo Carb is, we talk about advantages, has been instrumental in helping West Hills with these challenges, along with, the rest of the plant and the treatment train that was designed. Actiflo Carb is shown to be a very cost-effective solution to meeting DBP requirements. And it's also shown to, as I mentioned earlier, to be effective as a direct clarification step when we talk about clarifying a raw water source prior to media filters. And the last thing I would just highlight is it's not necessarily a mode of operation necessary for West Hills, but any Actiflo Carb system is capable of dual mode. And many Actiflo Carb systems in the U.S. operate that way, where they seasonally will add carbon as needed and operate in that carb mode where they inventory a large amount of carbon. And typically it's in the summer months, maybe late spring, summer into early fall, where they may operate in carb mode for taste and odor issues, enhanced organic removal to DBPs as algae and other things present problems for that facility. So Actiflo Carb has that capability of operating dual mode. And then in the winter months when either flows are low or organics are low, you can transition, not add the carbon and transition to just Actiflo mode. So it has that dual mode capability. So with that, I thank everyone for attending today, and now we'll open it up to answering any questions.
Awesome. Yeah, thank you all for your presentations and for giving all this information. We do have some questions already flowing in, so we'll start with this one. The water quality feed of the sources did not include nitrate. Is this not a prevalent issue in your area?
So Rich or Billy, I will defer to you guys on that one.
Yeah, the surface water doesn't have much nitrate in it. The groundwater has some, but the surface water is very low.
Gotcha. Cool. So I have another one here. Is there a difference in the separation of the GAC and sand in the separator? What is the criteria for the microsand dose?
Good question. And this is, again, Reed Staten with Veolia. So the separation device is sized and designed to be very efficient at removing the microsand. So we look at the size of the sand and size that cyclone to make sure that it's efficient at separating the sand from everything else. And so through the centrifugal forces and the various diameters within that cyclone, we can size it to be very efficient at removing pretty much anything larger than a given set size. And so that way we make sure we capture and separate the sand, and the lighter, fluffier material, the PAC, and any solids are more effectively discharged. And of course, in Actiflo Carb mode, then that PAC is recycled back to the head of the plant. So it really comes down to the sizing of the hydrocyclone to make sure that you have good separation between the sand and the PAC particles.
Cool. This one might be more for Billy. Does the plant meet long-term to advanced surface water treatment rule removal / inactivation requirements?
Yes, it does.
Cool. And then I have another one here. Any thoughts on the settled NTU trending upward?
Real quick, Billy, I mean, you may want to add to that, but I think on average, the data that we showed, there were some trends, upwards, but I think as Billy mentioned, those are just random blips on a day, but on an average perspective, the numbers were 0.5, 0.6, and I think Billy, you said even lower, right?
Yeah, they don't really trend. Those numbers are kind of like Reed said, just kind of a snapshot of a certain time, but they don't tend to trend upwards. They stay pretty steady. Like I said, kind of like on our daily routine, that's another instrument that we clean daily, that some of the carryover out of the lamellas can start building up on that and give you a false read. So that's something that we pull and clean the lens on that also daily. But we're pretty much on an average, I would say. We're at about a 0.14 to 0.15 on our settled water NTUs.
Excellent. Got another one here. What are the criteria for starting up the seasonal carbon filtration?
So, Reed Staten with Veolia, from a seasonal perspective, when you operate in Actiflo Carb mode versus Actiflo, it's really driven on what you're focused on. We talk about that Indianapolis facility. Their main driver for bringing carb online with the carbon is taste and odor, and so they'll monitor taste and odor, and as they start to see, seasonal variations in that and increases with that, they'll bring the carbon and introduce the carbon and transition into carb mode. And then we have other facilities that will predominantly run it for a set period of time. So they'll bring it in early spring or late spring, kind of get it going in carb mode, and get it online in preparation for their seasonal variations. And that includes TOC, algae, anything that you're focused on, you plan ahead. Typically, like Billy mentioned, you monitor your influence sources, and you probably have a historical good feel for when things start to spike on you. So most plants will get carb up and running ahead of time, and then they'll just adjust between carb mode and Actiflo only mode as needed based on the compounds they're trying to remove.
Excellent. Thank you so much for that answer. And how do you keep the zebra mussels from clogging intake screens and pipes?
Rich, Billy, do you guys potentially have any input there?
Yeah, Rich had mentioned that to keep the lower DO in the reservoir. As far as our actual facility, the fact that we're administering sodium permanganate, which we found out is a very efficient way to kill the zebra mussels on contact, so we have absolutely no problem with them downstream at our plant.
And I think that's fed at the pump station. Is that right, Billy? The permanganate?
Yeah, that's right down at the pump station. So it's at the very, very, very beginning of our process. So in the 3 years, we've had a few pumps pulled apart. We've had a few valves pulled apart. And we haven't seen any indication of any growth at all.
Right.
Cool. So now this is kind of seems along similar lines here. Do you collect plankton samples to identify taste and odor contributors?
Billy, Rich,
I do not believe we do. No.
I think the state does. You can get that for San Luis Reservoir.
Gotcha. Okay. Next one here. Can Actiflo Carb just be operated just as Actiflo? Can the PAC be turned off?
Absolutely. We've seen with Veolia, it can. As mentioned, it can transition between Actiflo and Actiflo Carb mode. Really, the only addition is that upstream absorption tank, and of course the carbon addition. So that carbon addition can be turned off. The concentration can be bled and sent to waste and easily transition into Actiflo mode, and then vice versa. Going from Actiflo to Actiflo Carb, it's just a matter of adding that fresh carbon dose and building up the system concentration by recycling the majority of your carbon. So it's relatively easy to transition between both modes within the same treatment train.
Cool. Got another one here too. Is the PAC dosage in Actiflo Carb similar to the classic PAC dosage and loss dosing prior to settling?
Yeah, Reed Staten with Veolia again. What the benefit of Actiflo Carb, right, is it inventories a large amount of carbon and keeps it within the system. Maximizing the absorption sites on those packed particles. And what we found is this is a more efficient usage of your dose compared to just once passed through systems where your carbon's added up front, and then by the time you get to the end of the process, it's discharged. So yes, because we keep it within the process, for a longer extended period of time and make the most of the available adsorption sites, there is a reduction in the required amount of carbon.
Cool. Oh, we got another one that might be for you too. Are older Actiflo able to be retrofitted to Actiflo Carb?
Yes. As mentioned, Actiflo Carb is the combination of your Actiflo with that upstream absorption tank. There are some components associated with the recycle stream that need to be incorporated, but yes, it is easy to retrofit an existing Actiflo to accommodate the Actiflo Carb process.
But the surface overflow rate is much lower. You should mention that.
Yes, there is. Depending on the flows and what you're trying to achieve. We talked about the rise rates through the Actiflo as compared to the Actiflo Carb. There is because of carbon, it's very light. Even though we're binding it to ballast, there is a slight derate that has to happen, and we can help you take a look at that if you're interested.
Cool. I think this is going to be another one for you. Up to what TSS concentration can the Actiflo Carb work?
So, as seen with West Hills, Actiflo Carb, again, takes the benefits of ballast declarification, and it is essentially a very efficient clarifier. And so Actiflo Carb can't operate as a primary clarifier. Obviously, carbon, it's not selective. It will absorb, what's ever in the raw water. So if you have a facility that's prone to influxes of other things beyond what you're trying to remove, what you may find is a slightly higher dose to achieve, whether it be organic removal or pesticide removal or what have you, if the carbon is being interfered with by other compounds. So it can handle a higher concentration for sure, and I think that's presented in the data from West Hills.
Awesome. I got another one here that's probably more in Billy's wheelhouse. Do you have fluoride deficiency in surface water? If yes, how do you make up for it?
No, we do not have a fluoride deficiency, and we don't administer fluoride like some of the bigger cities do. We don't have that implemented here.
We did have a couple more questions in the queue, but we do have to end the webinar. So this wraps up the Q&A section. Any questions we didn't get to, we'll answer offline. But on behalf of Water and Waste Digest and our sponsor, Veolia Water Technologies, I'd like to thank everyone for your participation. This webinar will soon be archived at the exact same URL you used today and on www.dmag.com. And it can be viewed on demand, so feel free to share it with others. So long, everyone, and thank you for being so engaged.